So in this video we are going to discuss about demultiplexers, right? So what is demultiplexer? If you rotate a multiplexer by 180 degree, then it will be a demultiplexer, and it seems like this. Suppose this is my demultiplexer and I have here 4 outputs. And this is my 1 input. So this is 1 into 2 to the power 2 demultiplexer, and it has selective lines of here 2. It happens in 1:2 to the power n input output ratio, and n is selective lines, right? Now what it is there is 2 selective lines, so I have S1, S2, and I will be having, suppose S1 and S0, S1, S0 as first 0, 0, 1, 1, then 0, 1, 0, 1, and then I will be having my outputs. So this is output 1, this is output 2, this is output 3, this is output 4, and suppose for first this is 1, and then second for this is 1, then for third this is 1, and then fourth this is 1, and rest are 0, right? Right, and then what I am having, this means it is enabled, right? All are enabled, right? When this is the case, then output 1 is enabled, right? And then when this is the case, then output 2 is enabled. Then when this is the case, this input is enabled, and when this is the case, this input is enabled, right? Now I have to propagate my input variables, right? And this can be also seen like this. Here are my 2 inputs, I1, I2, and here I am having 2 into 1 multiplexer, this joined by I1, and this is 1:2 multiplexer, and this is output 1, output 2, right? And I will be having a sender side and a receiver side, right? And then what I am having, suppose my ABR 0, 0, then 0, 1, 1, then 1, 0, 1, and then I am having my, right, this is input 1, output 1, this is here you can see when B is 0, right, output 1, and then when B is 1, I will be having output 2, and here I will be having what? In case of A, it is 0, so I2, right? A, here it is, sorry, this is I1, here it is 1, so I2, and 0, then OP1, and here I2 and OP2, right? And then what I am having, let me discuss about that decoder. So what is decoder? So decoder has multiple inputs and multiple outputs, right? Multiple input and outputs, right? Multiple input and multiple output device, right? And then it is combinational circuit that converts n lines of input into 2 to the power n lines of output, right? And application is, it converts binary code to what? Octal, then binary code to hexadecimal, and then binary code to decimal, right? And this is in the form n:2 to the power n. And the same but opposite case for encoder. In encoder it is 2 to the power n is to n, and this all is reversed, that is octal is converted to binary code, hexa is converted to binary code, and decimal is converted to binary code, right? And this can be written as the form n into 2 to the power n. For octal it can be written as 3 into 8, that is 2 to the power 3. For hexa it can be written 4 into 16, that is 2 to the power 4. And for decimal it is written 4 into 10 to the power 10, right? So it is 10 is less than 2 to the power 4, that means it can be less than, right? 2 to the power n can be less than 2 to the power n, right? Number of what? Number of, in case of decoder, right? And in case of encoder also, right? Right, here output in case of decoder and input in case of encoder, right? Now let's discuss on the next topic. Let's discuss about the working. So let me erase this first. So let me erase this first. This can be written like so. Let me write this. I have suppose decoder of 3 into 8, right? And this is x, this is y, this is z, right? And I am having what? D0, D1, D2, D3, D4, D5, D6, D7, right? And D8, right? And then this is x, y, z, right? So what I will do, right? Suppose I am having my x, y, z, right, as 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Let me make a table like this also. And this is 0, 1, 0, 1, 0, 1, 0, 1. And here is my D7, here is my D6, D5, D4, D3, D2, D1 and D0, right? So I have what? Accordingly, suppose for D7 I have 1 here, for D6 I have 1 here, here, like this diagonally, and rest I am having 0, right? Right, rest I am having 0, right? So what I will write here, SOP, I will write what? X bar, Y bar, Z bar. For this, X bar, Y bar, Z bar. For D1 I will write X bar, Y bar, Z. For D2 I will write X, Y bar, X, Y bar, sorry, yes, X bar, y, and then z bar. Then for D3 I will write x bar y z, right? In this manner I can write, right? And for D8 part I will write x y z, right? And suppose D is my enabled pin, and this is the way I can write my SOP, right? And same I will do for case of what? Case of encoder, right? What I will do, I will make here what? Here accordingly E1, E0, E1, E2 up to what? E8, this is E, right? And here I will be having Z, Y and X, and same I will make X, Y, Z, and I will start from E0 and I will similarly write in this manner, right? Now let's now move on to the next topic. We will discuss about what? Self-dual function. So let me erase this and let's start new topic. Self-dual function. Okay, let me erase this again. Fine. Self-dual function. Now, a function is said to be self-dual if and only if its dual is equivalent to the given function. So suppose I have f x y z is equal to xy plus yz plus zx, right? And this I can write this multiplication as plus, so x plus y, this as y plus z, and this as z plus x, and here in exchange of addition I will give here multiplication, right? And now I will expand this, so what I will get? I will get xy plus xz plus yy, which yy will give me y, and I will get yz into z plus x, right? And then I take y common, so I will be having x plus 1, right, plus z. So 1 plus anything will give me what? 1. So this will be y plus what? I will be having, right, I will have z plus x, so this will be xz, right, into z plus x, so I will be getting yz plus yx plus x again z plus x again z. This will be xz, and this I got what I started with, right? So this is, yes, self-dual function. Now, yes, now let's discuss how many self-dual function with one variable, right? So suppose I have n number of variables, then total number of combination I will get is 2 to the power n. Total number of Boolean function I will get is 2 to the power n, and number of self-dual function I will get is 2 to the power n minus 1, right? And for logical expression 0, 1, a bar, right? I have to find this. So I will make here a 0 1, right? And suppose I have s1 as 0 0, s2 as 1 1, s3 as what? 0 1, and s4 as 1 0. So what is this? Suppose I got now, right, this is 0, this is 1, this is a, and this is a bar, right? So for a and a bar it is dual function, for 0 1 it is not dual function, right? So this was an example. So this is all for today.